Welcome back, everybody. We're going to finish up 11.2 right now with working on some examples. Let's just jump right in. So let's say we've got 2 points. A is 0, 1, 2, and B is 2, 4, 0. We can take a second to write those out. 0 in the X direction doesn't go anywhere in the X direction. 1 in the Y direction is right 1, and Z2 goes up 2. We're right there. And then if I want to do 2, 4, 0, I'm going to go 2 in the X direction and 4 in the Y direction. Notice I'm putting in dots because going 4 right from this point right here is not the same thing as using the 4 along the Y. So it can be kind of tricky to draw these, but I thought I'd do some of them in person. And we're starting at A and we're going to B, so there's my vector AB. If I wanted to find a unit vector along AB, maybe we'll call it AB hat. What do we got to do? Well, we need to find the vector, the length of the vector, because remember, when we find the unit vector, we divide by the magnitude of the norm. So let's do that here. We calculate AB by doing the end point B minus the initial point A. So B minus A is 2 minus 0, 2. 4 minus 1 is 3. And 0 minus 2 is negative 2. I've got AB is 2, 3, negative 2. When I calculate the norm of it, I take the square root of the sum of the squares of the components. So we'll square 2, 3, and negative 2. That's 4, 9, and 4. We add them up, we get 17. So the magnitude of AB is the square root of 17. To find a unit vector along there, we just divide the vector by that magnitude. So we've got 2 root 17, 3 root 17, and negative 2 root 17. Now, if I wanted to find a vector of length 4 along there, let's just say I was calculating that to get the heading, and I want to find a vector starting at A that goes 4 in that direction. I can take that unit vector and multiply by 4. So this is one application of finding norms. We want to get a length in a certain direction. So we just multiply it in doing our vector or scalar multiplication. And we get 8 over root 17, 12 over root 17, and negative 8 over root 17. Okay. Some examples here are resultant forces in physics. I use a lot of physics examples because, let's face it, in 3 dimensions, making something 3D very much and easily applies to the real world. So when we have 2 forces, F1 and F2, and they're applied to an object, the combination of the forces is called the resultant force, and it's done through addition. So we've got 2 forces here. One is 6 newtons at 60 degrees off of the x-axis, and the other is 2 newtons at negative 30 degrees off the x-axis. What does that mean in terms of the vectors? Like if I want to draw it, which I kind of do, what does that mean? So let's calculate it. We've got the force, the magnitude is the newtons. So we'll calculate that by using the magnitude times the cosine and sine of each angle. So F1 is 6 cosine 60 and 6 sine 60, which would be root 3 or 3 and then 3 root 3. We do the same thing for F2. 2 is cosine negative 30 degrees and 2 sine negative 30 degrees. And we get root 3 and negative 1. So when we draw it, I've got F1 is about there. I put it in a calculator. I forget what I got. I didn't write the decimal equivalents of what I got, but I put it in a calculator to figure out what I got. 3 root 3 was a little over 5. And so that's 3 root 3. We've got root 3 negative 1. Root 3 is like 1.7-ish. Down 1. I know my graph isn't perfect, but it's good. The resultant vector, when we do addition, is that vector that goes along the diagonal of the parallelogram. So here is our resultant vector, F. And it makes an angle off the x. And since it was reported, F was reported in terms of strength in newtons and angle off the axis. I kind of want to return the same thing. But I didn't do that. Yeah, I did. So we've got F is here. When we're adding them, I just added these two together to get this. 3 plus root 3, and then 3 root 3 minus 1. There's our resultant force. I write those as decimal components. I get 4.73 and 4.20. That is how I got that coordinate, or drew that in right there. And so I did theta equals tangent inverse of that. And we should find the magnitude, which I didn't do already. Look at that, fail. I'll just use these rather than those. It'll be slightly inaccurate, but 4.73 squared plus 4.2 squared. And then I take the square root of that, is approximately the magnitude of the resultant vector is approximately 6.3 newtons. 6.33 if I did 2. And that will wrap up this chapter. Peace.